We are going to be starting on page 1 in the notes, doing our last operation that we didn't talk about yesterday, which is dividing. Now, the thing with radicals is we don't actually divide them. You're like, well, that's weird because I totally see dividing by the radicals there. What we do instead is we rationalize the denominator, or get rid of the radicals in the denominator. So get rid of the radicals in the denominator. So it's a rule. It's just not proper to have radicals in the downstairs. So how we get rid of the radicals in the denominator is we're actually going to use the good old creative forms of 1 like we did in the last unit. So use creative forms of 1. Because we don't actually want to change the value of the fraction. We just want to change the way that it looks. So that's another thing that's kind of nice, is just like the non-variable operations we did yesterday, we can actually check the accuracy of these based on what our calculator tells us. So we've got 2 radical 3 over 3, and the problem is we cannot have that 3 in the radical in the denominator. So how we get rid of a radical is we multiply it by something that will give us a perfect square. 3 times what gives me a perfect square? 3 times 3 would give me 9, and then 9 is a perfect square. So usually what you are going to do is multiply by the radical over itself as the creative form of 1. So now, yes?
Would there be a situation where you would multiply it by something else to get it to be a perfect square?
Yes. So when we get down into something like this one, where I have a radical and an additional number in the bottom, then we're going to have to multiply by something different. So let's go ahead and put stars by E and F, because those ones are a little bit tougher. So on this one, when we go to multiply straight across, we multiply 2 times radical 3, which gives me 2 radical 3. And then on the bottom, what's radical 3 times radical 3? Radical 9. And then, can I simplify the square root of 9? It's just 3. And voila! No more radicals in the denominator. So numerator is fine to have a radical, denominator, not good. So as promised, we will see how we can use our calculator to check to make sure that this really is the same thing as what we started with, and how this one is just a better version of that with no radical in the denominator. So there's 2 divided by radical 3. There's 2 radical 3 divided by 3. So I know it's kind of strange, because it's like, it really just looks like we made the problem a little bit more complicated. Instead of just having these 2 items, we now have a radical on the top instead of on the bottom. So the whole goal with this is we want to move those radicals out of the denominator. Yeah? So we're going to go ahead and move on to the next one. So we identify our operation as division, and we can't divide by a radical in the denominator. So what can we multiply radical 7 by to change it to be a perfect square under the radical? Radical 7 over radical 7. We multiply straight across, and that gives me 5 radical 7 over radical 49. And what is the square root of 49? 7. So then I get 5 square root of 7 all over 7. Can I cancel out this 7 with that 7? No! Why?
Because you can't.
Because that one's trapped under the radical. You can only cancel out the outside stuff or the coefficients with each other. You cannot cancel out the radical stuff. So that is my rationalized answer for this. Moving to problem C. Now C is a little bit different because we are taking the square root of an entire fraction. Next to this one, I want you to write distribute square root to top and bottom. Distribute the square root to the top and to the bottom. So if I have the square root of 6/5, that is going to be the same as the square root of 6 divided by the square root of 5. I distribute it to the top number and to the bottom number. So that's all fine and dandy. Now it looks more like what we started with. But the issue is we have a radical in the denominator. So what am I going to multiply by to get rid of that radical 5? Radical 5 over radical 5. So what's radical 6 times radical 5 going into the multiplying we did yesterday? Radical 30. And then on the bottom, we get radical 25, which simplifies to be 5. So I'm skipping a little bit of work there. Instead of showing the square root of 25, I'm going straight to the 5. Can I divide radical 30 by 5? Can I simplify that anymore? No. Let's go ahead and look at the next one. Now, we've got the square root of 27 on the bottom, which we're going to need to get rid of. But is anything jumping out at you about the square root of 27? Can we simplify that?
Yeah.
We can. So simplifying first, which is what I said yesterday, trying to simplify first, is good pretty much everywhere except the multiplication of cubic roots and fourth roots, where sometimes you create different pairs of numbers. So I would recommend simplifying this first. So then 3 over biggest perfect square I could take out of 27 would be 9. Which leaves us with the 3 left over. And I get 3 over 3 radical 3. Can I simplify that any further?
Times it by 3. Oh, wait.
So we can cross off the 3's, which leaves me with a 1 on the top. So if I have 1 over square root of 3, what do I now multiply by to get rid of the radical? By or rad 3 over 3. Which gives me rad 3 over square root of 9 or 3. Now, if you're like, what happens if I don't simplify first, Mrs. Cairo? I'll show you. We just take 3 over the square root of 27 and multiply it by rad 27 over rad 27. We get 3 rad 27. And then something big and awful under the square root, but what do we know it's going to be equal to? 27. So now I can simplify the 3 with the 27, which leaves me with 9. But then I got to simplify that radical. Be 9 rad 3 over 9, just 3. 3 rad 3 over 9. Are we seeing that this is just not as great? I mean, that's almost the same amount of work, but it is just a bit more clunky to get to the same final answer. So simplifying first means smaller radical, less simplifying to do at the end. Any questions? So no radicals in the denominator. Try to simplify first. So now we're going to move into problem E, and I'm actually going to box this off. Because to do E and F, we need to do something a little bit different. If I were to multiply by a radical 3, let's just show this on a piece of paper. So if I took that radical and multiplied it by rad 3 over 3, what that would give me on the top is 2 rad 3. But on the bottom, I would need to distribute that to both, which would give me rad 9, or 3, plus rad 3. Does everyone see what I did there? So if I multiply that bottom by rad 3, since that's a binomial, rad 3 times rad 3 gives me not rad 9, or 3. And then rad 3 times 1 gives me rad 3.
So we'll just keep going in that loop.
Yeah, then we just keep looping. It's like, that didn't get rid of my radical. It just made my number a little bit bigger. Instead of 1, we now have 3. And now I've got another radical over there, and then another radical on the top. So if I try to keep multiplying by radical 3 to get rid of it, is it going to work? No. So when I have a binomial, so this is our rule, for binomials, we multiply by the conjugate. Now, conjugate is a fancy word that basically means same stuff, different sign. For binomials, multiply by the conjugate, same stuff, different sign. It kind of has the feelings of difference of squares, because when I FOIL difference of squares, what happens to my outside-inside products? They cancel, and I'm left with the first term and the last term. So it's kind of similar to what we did there. So the first thing I'm going to do on problem E, I'm going to trap that binomial in parentheses to make the FOILing a bit more obvious. For my creative form of 1, I am going to use the conjugate of the denominator, which is the same terms, so rad 3 and 1, but with a minus sign instead of a plus sign. So same stuff, opposite sign. And if you're like, ew, I don't like that we're going to have to FOIL. Yeah, but just multiplying by a monomial term wasn't getting rid of the radical for us. So it is a little bit grosser, but it is going to get the job done for us. So let's start with the top. Since that's a binomial, we'll distribute the 2 to both of those. So 2 rad 3 minus 2. All good with that? So now on the bottom, we're going to FOIL. So I'm going to show all the work here. So rad 3 times rad 3 is rad 9, right? Which is a perfect square. Rad 3 times negative 1 is negative rad 3. Positive 1 times rad 3 is positive rad 3. And 1 times negative 1 is negative 1. If you're like, doesn't look like you did the job, Miss Cairo, well, we've got a bunch of stuff on the bottom, but look at what happens. Negative rad 3 and positive rad 3, goodbye. And what happens to rad 9? It's 3. So on the bottom, I end up with 3 minus 1, or 2. So I have 2 rad 3 minus 2 on the top, and then just straight up 2 on the bottom. Can I simplify that? Division distribution, take a 2 out of both of those, and we get rad 3 minus 1. Yes?
You didn't need to distribute the 2 at first then? Can you just write like 2 parentheses 3 minus 1?
I would always distribute it out. This is kind of a rare case where we can simplify it at the end, so you do want to carry out the operation and have it in simplified form. We kind of don't do GCF or factoring stuff with these.
Right.
Good question. So folks, as you can see with the FOILing, there are lots of little places that math errors can occur. So I want to show you how to check yourself on your calculator. Going back to what we did in the last unit, if I plug this in, what do I need to write after the division sign? Parentheses. So make sure when you type that in on your calculator that you include parentheses. So square root of 3, arrow over to escape the radical, because if I just do plus 1, that plus 1 is going to be underneath the square root. So there's what I start with, yuck, and this is what I end with, same yuck. So we get the exact same thing. Folks, this is a great way to check yourself if you're worried about making little mistakes in your multiplying work. So that's division, or rather, rationalizing the denominator. So folks, this is probably like the nastiest type of problem that you can have with these when I have a binomial on the top and a binomial on the bottom. So first we go, ew, a radical in the denominator. Let's get rid of it. Trap, 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 trap. What are we going to use as the conjugate for the denominator? 4 plus rad 5. And then the same thing on the top. 4 plus rad 5, because we don't want to change the value of the fraction. We want to just multiply it by 1. Now, when you FOIL, you have to be very careful about what is a coefficient or an outside number and what is inside a radical. So, radical 2 times 4, 4 radical 2. What about radical 2 times radical 5? Radical 10. Inside products, 2 times 4 is 8. And last terms, 2 times rad 5, 2 rad 5. We look at that top. Are there any radicals we can simplify? Let's see. Nope. Do we have any like terms or like radicands? No. So the top is good as is for right now. So now moving on to the bottom. First times first, 4 times 4 is 16. Outside terms, 4 rad 5. Inside terms, negative 4 rad 5. Now, the last product a lot of times throws students off. Folks, when I multiply those, what do I get?
Negative.
Thank you! Negative square root of 25. I would highlight that minus sign, because that sign usually gets missed when we're multiplying the radicals together. All right, so simplifying the bottom, 4 rad 5 and negative 4 rad 5, goodbye. And I get 16 minus 5. What's our new denominator? 16 minus 5 or 11. We have run out of room. So this top part over 11 would be our final answer. We would not want to do division distribution because none of those would come out evenly. So unlike the last one where I could take a 2 out of both of those, none of those are divisible by 11. So it is good just the way it is. Division. Woo! In the blue. Not packet sheet. Did you need to see that? Yes. It was all this business over 11. We just ran out of room. All right, folks, we're going to go ahead and go into the blue sheet. Where is you guys? There it is. We're going to do the blue sheet. Starting with number 3. We see we have division. Gross. We see we have a radical in the denominator. Gross. Let's get rid of it. There's something else that might be jumping out at you about that numerator. That radical 50, is that simplifiable?
No.
Is there a perfect square we can take out of 50?
No.
25.
25. So we're going to go ahead and start by simplifying that radical because these problems are hard enough as is. The smaller the numbers, the better off we are. So let's see. We'll have 3 minus radical 25, radical 2. Square root of 25 is 5. So 3 minus 5 rad 2. So that's my simplified numerator. There's my simplified denominator. What are we going to use for our conjugate or create a form of 1 on the bottom?
5 minus rad 2.
Perfect. So 5 minus rad 2. 5 minus rad 2. So foiling on the top, foiling on the bottom. Folks, I want you to try this one on your own. Once you get a final answer, compare with someone sitting close by to you. Be very careful with your signs when you are foiling and show as much work as you need.
square root of 4. Square root of 4 equals 2, which would end up being -10.
Once you get your final answer, you can also practice typing it in on your calculator to make sure you got the same thing that you started with.
Scarlett,
Hmm.
did it even out to 10? When you times the square root by the square root of the -5.
Yes.
Okay. No. Positive or negative?
Positive.
I bet. Oh. So the -5. The -5, and there's always a -1 in front of it, which equals +5. So it's +5 times the square root of 10. Because the 5 times the 2, square root of 10. So
How do you get the square root?
yeah, 2 times 2 is 4. Square root of 4 is 2. So then you had a -5 times a -2. So then equals +10. Right? So you have 25 on the top and the bottom of the square. This is so fun. I can't wait to use this in my world.
You know, well, I understand the part of it. I understand how you got it.
All right, folks, so let's start with foiling the top. 3 times 5 is 15.
Wait, what's under your hand?
Not.
We're walking through.
She doesn't want you to.
I don't want you to
understand
see it yet.
It's not.
Now, if it helps you, folks, anytime you have a radical and you're like, what's the coefficient? You can put a 1 in front of it. So when I do my outside products of 3 times -1 rad 2, 3 times -1 would be -3, and then the rad 2 gets stuck on the end. My inside product, -5 times 5 is -25, and then the rad 2. And then for the last product, -5, the coefficient, times -1 is 5, and then rad 2 times rad 2 is 4. Now, I did the simplifying work above this. 5 times the square root of 4. 4 is a perfect square, so it's 2. 5 times 2 gives me 10, so that's what I end up getting for this part. On the bottom, when we FOIL, 25, -5 rad 2, 5 rad 2, and rad 2 times negative rad 2 is negative rad 4, which simplifies to be -2.
What's the?
It's so complicated.
What's
It's
the-
complicated.
What's the 5 rad 4 that's x side?
So 5 rad 4 simplifies to be 10. So then when I go to simplify the top, 15 plus 10 is 25. I'll underline that.
Oh, okay, got it.
And then these two are like terms. -3 rad 2 and -25 rad 2 is -28 rad 2. And then on the bottom, these cancel, and I have 25 minus 2, which is 23. As you can see, the division problems are the hardest because it puts everything together. Finding the conjugate, foiling, multiplying, and adding. Good question?
It's the hardest part of the whole unit.
I think the dividing is probably the hardest thing that we do in this unit. So,
Is there any graphing?
nope, we don't do any graphing in this unit. Now, folks, number 4. Let's see what you remember from yesterday with multiplying. Coefficients times coefficients, radicals times radicals, and then simplify.
Wait, would you do y2 times y1 equaling, or did you add them? Y3?
Obviously different.
So you're multiplying the bases. So Mad Spam says we do what with the exponents?
Add them.
Correct.
Oh, you
So 2 times 4, 8. Then multiplying the radical stuff, 8 times 3 is 24. Y squared times y to the first, adding those, y cubed. And z times z, c squared. Now, I have carried out the operation, but after we do that, our final step is always to check to see if we can simplify further. Is there anything we can simplify here? Yes. What's the biggest perfect square I can take out of 24? 4. And that would leave me with a 6. Now, y cubed, if I divide that by the index, what is the index of a regular square root? 2. So, what can I break y down into that is divisible by that index of 2? And something that is left over. Perfect. Y squared for the perfect square factor. And then y. So we're breaking the power down into something I can divide by the index of 2. And whatever is left over. Is y squared times y going to be y cubed? Yep, we're just breaking it down into factors, just like we did with this 24. Pew, 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 pew. What's the square root of z squared?
Z.
Z, just straight up z on the outside.
Wait, why don't we have the square root sign?
Because when we divide it by the index, we have rooted it and the radical is gone.
The index is 2 because there's nothing there.
Yep, when there's nothing there, the index is 2. Now, as you can see, it's kind of messy right now. From working with fourth block yesterday, I had some students who were trying to group all the outside stuff together while they were doing this. It gets pretty confusing, which is why I just take it step by step with each individual part. And at the very end, I put all my outside stuff together and we put all the radical stuff together. So I'm just going to continue to bring things down. The square root of 4 is 2, joined by multiplication. Radical 6 stays radical 6. The square root of y squared is y. And then I've got this y left under the square root. And the z on the outside. So from here, I want to put my radical stuff together
So 6, 5, 6, 1.
and my outside stuff together. These are all joined by multiplication, so I can shuffle it. So what will I have outside the radical? 16 yz. Excellent. And what will I have underneath the radical? 6y. And I don't need to write the index of 2 when it's a square root, but you might find it helpful to write it up in your work when you are trying to take the power divided by the index.
Wait, you have to put the 2 back down?
You don't have to.
It's already applied.
That's only when I do when there's a 1, right?
Yep, if there's a cubed root or a fourth root. All right, folks. I want you to go into the homework packet, and you can now circle hashtag the rest. So all the problems that we skipped yesterday, you can now do. So you can do all the way through number 19, all of those division problems. Just to make sure we're all good. Yeah, 15. I want to look at number 1 since this was one problem that requires quite a bit of work and fourth block had some issues with it yesterday. So if you've already done number 1, great. You can go ahead and start working on those division problems, but this is a good problem that covers all those strategies of breaking the exponents. So first, our index of the radical is 2. Anytime you don't have a number written there, the implied index is 2. The square root of 36 is 6. It's a perfect square. I don't have to break it into 9 and 4. Those would both be perfect squares anyway. So if it's a square root, we evaluate the square root and just get 6. Now, what about a? Do I have enough a's to take the square root of it?
Yes. No. Yes.
We only have 1. How many do I need to do the square root of it?
You need
2. If I tried to do power divided by index, I would get a to the 1/2. We don't want that. So what happens to a? It just chills under the radical. It cannot come out because there aren't enough a's to actually evaluate the square root. Now for the b's, can I do power divided by index? Yes. So now we have b squared, no radical. So when I actually do that division, the mad spammered, when we root, we divide, and then no more root. Now, what about C? Do I have enough C's to take the square root? Yes, but we need to break it down into something that is divisible by 2 and whatever is left over. What's smaller than 5 that's divisible by 2? 4. And if you're like, can I break it down into C squared and another C squared and then a C? Sure, you can break it up into smaller factors if you wish, but breaking it into the largest one will be the easiest route. So C4 will be my perfect square. And then what's left over in the other radical? Just C. So now I have 6 times radical A times the square root of C to the 4th is C squared, and then square root of C. So I need to put all of my outside stuff together and all of my radical stuff together. So 6b squared C squared square root of AC. So your final step is swinging all that outside stuff out in front of the radical and mushing all of the radical stuff together. And I think what I'm going to do is I'm going to give you until lunch to ask questions and work on those division problems and practice. A little bit more work time after lunch, but then we're going to do a homework quiz over this first section just to see where we are at on all of these. Capiche? Let's work.